Hi everyone, my name is Rana Khalil, and today I'll be talking about securing open source dependencies. This is a topic that is near and dear to my heart, and so hopefully by the end of the presentation, you'll understand the third party risk that is introduced by the open source dependencies that your project is built on, and the different ways you can monitor and secure your open source dependencies to decrease or mitigate that risk. But before we do that, let me introduce myself. Again, my name is Rana Khalil. I have a bachelor's and a master's in computer science, and I'm OSCP certified. I currently work as an application security engineer team lead at a consulting firm in Ottawa, Canada. Now, as an AppSec engineer, I'm responsible for not only doing web app pen tests, but also for integrating security as part of the software development lifecycle. An important component of what we call shifting left or integrating security earlier in the SDLC is having visibility on the third party risk that is introduced by open source dependencies. And so we're going to talk about that today. Now, when learning about a new topic, I always ask myself three questions: the what, the why, and the how. So, for our topic today, we're going to be talking about securing open source dependencies. So, the questions we're going to be answering are: one, what are open source dependencies? Two, why should they be tracked and managed? And three, how can dependencies be secured? My aim for today is to have everyone in the audience be able to answer these three questions. And we'll start off with question number one, which is: what are open source dependencies? Now, you'll notice over here I have a ton of diagrams in my presentation, and they're all references to how the real world works. So for diagram number one right over here, which is taken from XKCD, you see that all the modern digital infrastructure at the top over here, it's all built on open source projects developed by people around the world. As we go along with the presentation, you'll understand how fragile the software ecosystem can be. I feel like people tend to underestimate the type of issues that can result from this type of system because they don't understand how big of a problem this can be. So, what we're going to do first is set the context to understand the scale of the problem, and then we'll talk about tools that have been developed to specifically address this issue. Now, to set the context, I borrowed a few slides from this amazing talk that was given at the Hack in the Box security conference titled Finding Vulnerabilities and Malware in Open Source Code at Scale, and it was done by Mark Curphey. The talk starts off by essentially talking about how people consume open source software, and it likens it to the making of a cocktail. The first thing you do when you're developing an application is you choose the framework for the app that you're developing. So let's say if you want to develop in Java, maybe you'll be using the Spring framework. For Ruby, maybe you'll use Ruby on Rails. For Python, maybe you're using Django or Flask, and so on. Now, the framework itself is open source. Then you need to add your own custom code for the custom functionality that your application is going to provide. And then you realize there's certain functionality that you want in your application that somebody has already implemented before. And so why write your own code and make your life harder when you could just use an open source library that has already implemented this functionality for you? So for example, if you want to, let's say, authenticate using Google or authenticate using Facebook, there's already libraries that do that for you. And so you just import these libraries. So what you end up with is essentially a cocktail of code where 90% of your code is open source code and only 10% is custom code that you've written. And while organizations spend considerable time and effort ensuring that their custom code, which again only makes up 10%, is completely secure, usually little to no consideration is put into evaluating the open source dependencies that make up 90% of your application. Now, 90% is a pretty big claim, so you might be thinking, I'm not too sure that's true. I'm looking at my codebase and I'm definitely only making use of 3 open source libraries for my application, and that can't be 90% of my code. Well, my answer to that is that while it might seem to you that you're only using 3 open source libraries, you're likely using much more than that. What happens when you request and pull down a library is that that library says, well, wait a minute, I need this library to survive. And so it pulls it down. And then this library says, well, wait a minute, I need this library to survive. And so it pulls it down. And then this library says, wait a minute, I need this library to survive. And so it pulls it down. And so, although it might seem to you that you're only using 3 libraries, what you're actually using is, let's say, 100 libraries. The libraries that you directly pull down in your code are called direct dependencies. Those are the ones that are in green on the slide. And then the libraries that your direct dependencies pull down are called transitive or indirect dependencies. And those are the libraries that are in gray on the slide. Now, if this still doesn't make sense, a really simple example that I've heard before is that imagine you invite 3 people that you absolutely trust to your party. But those 3 people invite 3 other people to your party. And then those 3 people invite 3 other people to your party. And those 3 people invite 3 other people to your party. And so on. And so, although you only expected 3 people will show up to your party, 100 people end up showing up. And you have no idea who these 97 extra people are and if they're going to trash your party or not. And that's essentially how dependencies work. Now, those were just examples. Let's look at some real world statistics to back up our claims. Synopsys does a study every year where they essentially do an in depth study of the current state of open source security, compliance, licensing, and code quality risks in commercial software. And the results are all summarized in a report called the Open Source Security and Risk Analysis Report. I've got the link on the screen in case you're interested in reading it. But to summarize, what they did is they essentially examined over 2,400 commercial code bases across 17 industries, and they reported that out of the 2,400 code bases, 97% of them contained some form of open source code. And then when they looked at each individual code base, they reported that 78% of each code base is made up of open source code. So approximately 80% of each application was made up of entirely open source code and only 20% was custom code. That's a significant ratio that can have major compliance, privacy, and security related implications, which is a great segue into our next section, which covers why should open source dependencies be managed. We briefly touched upon that in the past couple of slides, but let's go a little bit more in depth on that, not only from a security and a privacy perspective, but also from a functional and a licensing perspective. To highlight the scale of the problem from a functional perspective, a few years ago, a developer got upset that one of his NPM modules was asked to be taken down due to a copyright infringement. And so, what he did is instead of just taking down that one library, he unpublished over 250 of his libraries from NPM. And one of these modules was the left pad library, which was literally just 11 lines of code that padded something left. Now, this might seem harmless, however, this ended up causing a ripple effect that took down majority of applications that were built using JavaScript. So you had developers all over the world waking up to broken builds and failed deployments just because this 11 lines of code module was removed from the NPM repository. And the reason was because this library was embedded in the Express framework, which is a really famous framework for building Node.js applications. So the builds for all the Node.js applications built using the Express framework ended up failing because they couldn't pull down this library. Now, of course, after the incident, NPM did put measures to make it harder to unpublish packages that other packages or modules depended on. But if you really think about it, the fact that this happened is quite insane. And it really highlights how fragile this type of ecosystem can be. Now, this is from a functional perspective. What about the security and the privacy perspective? Well, let's talk about a really famous breach that occurred a few years ago, the Equifax breach, where the personally identifiable information, so PII, of hundreds of millions of people was stolen. Equifax was using the Apache Struts framework, which is an open source development framework for creating web applications. At the time, the version of Apache Struts that they were using contained a remote code execution vulnerability. And although Equifax was informed beforehand that they were using a vulnerable component, they failed to patch it in time, and so they ended up getting breached. And to make things worse, these are titles from articles that were published at the time. And you could see over here, one of them says code responsible for Equifax breach downloaded 21 million times last year. And another article over here says most of the Fortune 100 still use flawed software that led to the Equifax breach. So even after Equifax made headlines, most of the Fortune 100 still use the flawed software that caused the Equifax breach. This highlights the absolute importance of not just having visibility on your open source dependencies, but also having a proper and effective patching cycle to ensure that libraries are updated when security patches come out. A more recent example is the Log4j vulnerability that was released in December of last year. It affected millions of devices worldwide. I remember last year when I saw someone post on it on Twitter before the media picked it up, I thought, oh my god, we're screwed. Log4j is integrated in millions of Java based software and servers worldwide, and the exploitation of this vulnerability not only could lead to remote code execution, but attackers who exploit this vulnerability and get RCE could use it to install malware and other backdoors in the networks that they infiltrate. So it was a big deal. So when this came out, there was a worldwide public panic on figuring out if any of the software that you have in your network uses the Log4j library, which again highlights why it's super important to have what is called a software bill of materials, which is essentially a list of all the components that your application or software is using, and we'll talk more about that in the next section when we talk about securing open source dependencies. Now, the rise in the disclosure and exploitation of vulnerabilities like the Apache Struts vulnerability or the Log4j vulnerability is the reason that the use of vulnerable and outdated components was listed as the sixth most critical security risk facing web applications today. So, definitely something that needs to be considered when you're evaluating the security of your web applications. Now, if we go back to the Synopsys Open Source Security and Risk Analysis report, we see that out of the 2,400 applications that they analyzed, 81% contained at least one known open source vulnerability, and 49% of the audited code bases contained at least one high risk vulnerability, like the Log4j or the Apache Struts vulnerability that allows an external attacker to gain access to your network. That's a pretty scary number. It means half the applications they audited were using an open source library that had a known high risk vulnerability. Another thing that they looked at in the report that we're not going to spend too much time on because it's not from a security perspective, but it's still important, is the licensing issues. In some countries, like the US, creative work, which includes software, is protected by exclusive copyright by default. What that means is that you're not allowed to legally use, copy, distribute, or modify software without the explicit permission from the creator or author, and that permission usually comes in the form of a license that grants you the right to do so. And so, if the project does not contain a license, then by default it's copyright protected, which means that you're not allowed to use it. And the study found out that out of the 2,400 code bases that they looked at, 20% of them contained open source libraries that either had no license or had a custom license. So, no license means you're not allowed to legally use it, and then a custom license that has not gone through some kind of form of legal evaluation puts your organization at risk of the author potentially taking legal action against your organization. Now, the study also compared the different licenses available in each code base, and they found out that 53% of the audited code bases contained license conflicts. What that means is, for example, you make use of an open source library that allows you to freely use it, even for commercial use. But then you're also using another open source library that says you're only allowed to freely use it, but not for commercial use. Now, depending on the type of product you're developing, the latter license might open you up to additional levels of risk. And so, although this is not from a security and privacy perspective, it's definitely something that you should care about when it comes to the applications that you develop. All right, so we talked about the privacy, security, and license compliance issues that could potentially come with using open source software. Now, the question is, how can you avoid these types of issues? The first thing that you absolutely need is a software bill of materials, or in short, an SBOM. This is the list of all the open source and third party components that an application is using. Think of it as equivalent to a list of ingredients that you find on a package of food that you want to buy. So, just like I might want to know the ingredients of the food that I'm buying because, let's say, I have food sensitivities, in the same sense, I want to know the software bill of materials for my application so that I know exactly the risk that I'm introducing to my organization by using a certain software. Now, remember when we said that when you directly pull down a library, you're actually pulling down, let's say, 10 different libraries that depend on each other? So, this software bill of materials includes both the direct and indirect dependencies that your application is using. Depending on the software you use to create this SBOM, it might include slightly different information. The list that I have over here, which is the classic list of information that is usually included in an SBOM, is from the Software Package Data Exchange Standard, or known as SPDX, which is supported by all the major tools. Now, it became absolutely important to have this software bill of materials when we saw an increase in exploitation of vulnerabilities in third party software. In fact, just last year, it became mandatory in the US that you provide an SBOM for software vendors contracting with the federal government. We're not there yet in Canada, but it's definitely something that I see happening soon. And there are bills that are being introduced in order to make it a requirement. Now, creating this SBOM is not something that you could do manually because it'll take forever. So we saw that although you think you're pulling down 3 libraries, you're actually pulling down 100. So performing this task of identifying the direct and then the indirect dependencies can take forever. So there are tools that are called software composition analysis tools, or in short, SCA, that automate the process of generating an SBOM and then identifying known vulnerabilities in the open source dependencies and ensuring license compliance. These tools essentially work in 3 steps. The first one is generating the SBOM. So again, that's the list of all the direct and indirect dependencies that your application is using with the version numbers. The second step is cross-referencing this list with vulnerability data sources. So depending on the tool that you're using, the vulnerability data sources could be different. Some tools use the MVD database, which is the National Vulnerability Database. Others use things like GitHub issues or comments or private vulnerability databases or even a combination of different vulnerability sources. Of course, the more diverse your vulnerability data sources are, the more coverage you're going to get. Now, once you cross reference the list of direct and indirect dependencies with your vulnerability data sources, if you get a hit that says this specific version of the library that you're using is vulnerable to so and so vulnerability, then it gets outputted and logged in the report. And that's essentially how they work. Now, there are a ton of SCA tools out there. Some of them are open source, like Dependency Check, NPM Audit, Retire.js, whereas others are free, like Dependabot, which got bought out by GitHub and now is just available through a feature in GitHub that you could easily enable. And then you've got paid ones like Veracode or Snyk or Black Duck and many more. I don't want to endorse a specific vendor, so instead, what I'm going to do is discuss the features that you should consider when selecting an SCA solution. And the first one, and this is probably the most important one, is language support. So you've got a tool like NPM Audit. It can identify vulnerable NPM libraries. It can be used to identify Ruby libraries. Same goes for Dependable. Although it has support for many programming languages, it was mainly developed by JavaScript developers, and so it covers JS libraries really well. All the other languages, it does a mediocre job at best. So it's really important to make sure that the SCA tools you've chosen support the languages that your organization uses. The second thing that you should consider is the vulnerability data sources that the tool references. So, the more diverse the vulnerability sources, the more coverage you're going to get. Not everything is assigned a CVE number and gets logged in the National Vulnerability Database. Some vulnerabilities are reported through commit logs, through issue trackers, through social media, through private vulnerability databases, and so on. So, again, the more diverse the vulnerability sources, the more coverage you're going to get. The third one is accuracy. So, the tool's ability to identify if your application is using the vulnerable function. Just because you're using a vulnerable component doesn't necessarily mean that you're vulnerable. You have to be calling and using the vulnerable function for you to be vulnerable. And statistics show that majority of the time, you're not actually using the vulnerable function, and so you're not really vulnerable. Now, does that mean that you shouldn't update your software? No. It does, however, help in terms of determining the risk and prioritizing what gets updated first. So, if you do have a tool and can afford a tool that does both a combination of SCA and SAS, so static analysis, then it can definitely be much more accurate than a tool that just does SCA and doesn't have the ability to actually parse your code and see if the code is using the vulnerable function. Some SCA tools have the ability to auto-generate pull requests and update to a non-vulnerable version. However, this does come at the risk of breaking things when you update, so you want to do this in a test environment first. This is not an important feature to me, but I've seen organizations that care about this specific feature, and so I decided to include it. The fifth one is configuration and integration. So the tool's ability to be configured to, let's say, pull from different vulnerability sources or integrated in the sense that can be integrated as part of the technologies of the pipeline that you're using. The last one is reporting. This one is self-explanatory, so I'm not going to spend more time on it. Like I said, I'm not going to endorse a specific vendor, but what I'll say is from my personal experience, you get what you paid for when it comes to SCA tools. Tools that are free or open source are a good starting point, but you'll see that they're missing a ton of features that are absolutely necessary that are only available in paid SCA tools. So if you do not have the budget, definitely start out with the free or open source tools. They're great, they're a good starting point. However, when you do get a budget, I would recommend doing an evaluation of the paid SCA tools and selecting one of those to include in your pipeline. All right, we're almost done with the presentation. Let's look at an example of an SCA tool. So I wanted to show you how easy it is to set up and run an SCA tool. And in this case, what I did is I just downloaded the OWASP Juice Shop application, which is an intentionally vulnerable application that contains a ton of vulnerable dependencies. And then I downloaded npm audit because the application is written in Node.js. And all I'm going to do in this video right now is run npm audit and show you how easy it is to run the tool and the critical results that the tool reports that, if missed, could potentially lead to disastrous consequences. So if we play the video right over here, you could see that I run npm audit in the root directory of the Juice Shop application. I hit enter. It only takes a couple of seconds. If it's the first time that you run it, it might take a couple of minutes. And here we go. It says it found 76 vulnerabilities. 67 were low, 5 moderate, 2 high, and 2 critical. And a really important statistics over here that I didn't highlight is that it scanned 23,905 packages. This is why you need a tool for this, and you can't do this manually. Now, you could see over here for each specific vulnerability, it gives you some information about it. Over here, this is the critical vulnerability, which essentially allows you to bypass authentication as an unauthenticated user. So this definitely has disastrous consequences, and the developers would not have found it if they hadn't run the SCA tools on the application. And that's essentially it. That's all you have to do in order to evaluate if any of the open source dependencies that your application is using are vulnerable. All right, this concludes our presentation. Before I end, I wanted to circle back to the three questions that I said we'll answer during the presentation. So the what, the why, and the how. The first one was, what are open source dependencies? So we said that open source dependencies are open source software that an application uses. They come in two forms: direct dependencies, which you directly use in your application, or indirect dependencies, or also known as transitive dependencies, which are the dependencies that the direct dependencies pull down. Now, the second question was, why should open source dependencies be managed? To answer this question, we looked at real-world incidents and statistics from the Open Source Security and Risk Analysis report that was done by Synopsys to understand that open source dependencies need to be managed for the purpose of privacy, security, and license compliance. The third question was, how can these dependencies be managed and secured? For that, we talked about software composition analysis tools that automate the process of generating an SBOM and identifying vulnerabilities in open source dependencies and reporting any licensing issues. We also talked about the features you should consider when selecting an SCA solution. And that answers all three questions. I hope I've convinced you that this is an important issue that you should definitely consider when developing an application or when evaluating the security of the application. Thank you for taking the time to listen to me. I've got my social media links on the slides. If you're interested in learning more about web app pen testing and application security, feel free to visit my YouTube channel or academy. I'm most active on Twitter and LinkedIn. And so if you're interested in keeping up with the work that I'm doing, feel free to follow me on there. Thanks again for listening.